Okay, so here's what we're gonna do. We'll do the odds for this first part today, then the second video I'll come back and do the second block. We'll go back and do the evens. And again, these are fairly similar to what you should have. Again, may just change the numbers a little bit, but it's basically going to be these problems. Now, the one thing is when you take the final exam, it's all jumbled up in all kinds of different order. But the review, it's all the same, so we can kind of match up. But the exam's all jumbled up when it comes out to it. So this one gives you an expression here, and it says evaluate this one for x equals 8 and y equal to -9. So just take those numbers and plug it in. And again, if you ever aren't sure when you plug in a number, just put it in parentheses. So now it's 5 times 8, which is 40. 2 times -9 is -18. And 40 minus 18 is 22. All right, number 3. Solve the equation. We've got 21 minus 2 times 2w plus 1. That's equal to 13w minus 2 times 13 plus w. All right, kind of a long equation. But once we do a couple of things, it really won't be that bad. Biggest thing on this one is you do have some parentheses. So the very first thing you want to do is do -2 times both of these numbers. So it's -2 times 2 for a -4w, and -2 times a +1, which would be a -2. The 21 that was in front is just hanging out there. Okay, and same thing over here. You're going to do -2 times 13 and -2 times w. So that's -26 minus 2w. All right, and once you've done all that, now you can start moving numbers and doing different things around. Now here's where you can, if you want to, you can kind of save a little bit of work. If you rearrange the terms on the left-hand side, if you make this 21, put the -2 here and the -4w here. That way you can go ahead and do 21 minus 2 and just make that 19. And same thing on the right-hand side. If we just rearrange these last two terms here, bring the -2w up first and put the -26 behind it. That way you can combine some terms and make the work a little bit easier, because now you've got 13 minus 2 for 11w. Okay, so we take from having 6 different terms, and if you just rearrange the terms on the left-hand side to get the numbers together, you can just put these numbers together. It's 21 minus 2, so make that 19. This one again, rearrange this one so the -2w is right behind the 13, so it's 13 minus 2 for 11. Now you can start moving things from side to side. So if you want to move the w's to one side and the numbers to the other, we can do that here. I would say for this one, let's do a +4w so that we can get rid of the w's that's over here. So now we got 19 equals 15w minus 26. And then we'll add 26 to both sides. 45 equals 15w. And we'll divide the 45 and the 15 to find out that w would equal 3. Okay. Now, and again, you could have, back up here, you could have moved the, some people are saying, well, why didn't we move the numbers? Why didn't we change the signs here? Well, if they're on this, if you've got two numbers that's on the same side and you don't move them, if you just do 21 minus 2, if you just simplify that one, you can just work it out without having to move it from one side to the other. If you were going to do that, you would have had to go back and done a +2 here and then a +2 here to cancel that out. But since you can always rearrange it and just combine them together, you could do that and kind of save a few steps. Okay, number 5. This one is solving a compound inequality, and it's 9x less than or equal to -45, or 4x is greater than or equal to 24. Okay, and the solving on this one is really not bad at all because there's only one step to do on both parts of it. This one you're going to divide by 9. So this will be x is less than or equal to -5. This one you can divide by 4. So x is greater than or equal to 6. So the solving is really easy. The hardest thing on this one is knowing, okay, what do we do in an OR situation? And remember, if it's an OR, that's one of those things that you basically put those two numbers on the graph. So this one would be at -5 and 6. You want everything that's less than or equal to -5. And remember, the arrow tells you which way to go. So we want a solid circle at -5 going that way. At 6, we want a solid circle at 6 going that way. And what we said was that if you're doing an OR statement, most of the time, unless it's a trick question, it should look like ORs on a boat. That you've got the middle of the boat here, you've got the OR on this way, and the OR on that way. So that would be your answer. And if you're looking at, just pulling this sample test question over so you can see it, looking at this part of it, you can see that it's got the option right here that you can do the x less than or equal to -5 or the x is greater than 6. So you can pull that out. And then you've got the multiple choice down here. So then it's just a matter of making this part fill in with what the blank's going to be. So this one will wind up being D. And then if you go back to it, it's less than -5. Oh, there's more options. I'm going to say it's not there. There we go. So this one would be less than or equal to -5 and then greater than or equal to +6. So it would be D, and then fill in the -5 and the 6, and then the H for the multiple choice there. Okay, number 7. And this one, we'll just do this one on the screen because that's the easiest way to do this one. It says, here's a relation, is this thing a function? And remember, what you're looking for is that as long as there's only one arrow coming from the domain for each number, it's a relation, it's a function. So you've got the 1 pointing to the 15, you've got the 5's got one arrow, the 6 has got one arrow, and the 9's got one arrow. So this one, and again, it doesn't really matter for the numbers here, it's all in domain. As long as there's only one arrow from each number, it is a function. So this one would be a function. Okay, number 9. And again, we'll do this one on the part here so y'all can see it too. For this one, we're going to graph y is less than or equal to 2x minus 6. First thing is, I'll pull this down for just a second, is that you've got to know that if we're doing y is less than or equal to 2x minus 6, you've got to know what those two numbers are. So in this case, the 2 is your slope, which is making it a fraction, so it's 2 over 1. The -6 is your b value. Again, that tells you where to begin, so we're going to begin at -6 on the y-axis. And then the inequality sign tells you what to do. It's less than, so we have to shade down. And because it's got the bar underneath it, that means it's going to be a solid circle. Or a solid line in this case, because we're graphing this thing. Okay, so we have to start at -6. So we're going to begin at -6 on the y-axis. And then to get to the next point, we're going to go, because it's positive, we're going up 2 and then over 1. If that had been negative, we would go down 2 and then right 1. So for this one, again, we'll start at -6. So we need to, I'm going to zoom in just a little bit. We need a solid line. We're going to start at -6, go up 2 and over 1, which should put us there. And then we said it was y less than or equal to, so we're going to click on our bucket, and we need to basically go from the line, and we need to go down, so that means we got to be on this side. Save it, there's our line. Let's check it, make sure everything is good. It should be, if I can get it there. And we'll check it, and we are good to go. Okay. Okay, number 11 says identify the inequalities for which the order pair 2, 1 is a solution. And this is one that it's really pretty easy. You basically know that the order pair 2, 1 is basically find that point and you have to go back and see, all right, is 2, 1 in the shaded region on this graph? Make sure your scale. Now, if you notice on this, the only thing you really got to watch for is the scales. For this to be 10, this is 2, 4, 6, 8. Yeah, these are all by 2s. So 2, 1 would be halfway up. That looks like that one would be in on that graph. So that one's good. And you may have more than one correct answer, so we may have to go back and check this one too. For this one, it's not. Yeah, if you go over 2, up 1, that's right here. That's not in the shaded region, so B is not in. And then for C, we'll zoom in on it again. 2, 1 is right here. That's in the shaded region, so that one's also there. So there should be 2 answers for that one. Okay, says input's correct. All right, 13. Solve an equation with any method. So we have 7x squared minus 19x minus 6. Okay, this is the big boy. So 7x squared minus 19 minus 6 equals 0. Okay, first thing I would always do for a problem like this is I'm going to try factoring first. So now if it was just x squared minus 9, that would be easy. We'd look for the factors of 6. That would be 19, but because it's 7, we've got to do the AC method. So first thing we're doing is 7 times negative 6, which is negative 42. So we're finding the factors of negative 42 where the sum is going to equal negative 19. Okay, and then just go through your list of numbers. It's not 1 and 42, 2 and 21. That might work because if you subtracted 21 minus 2, that would be 19. The B term is negative, which means the bigger number has to be negative. And if we divide 2 negatives, that's going to give this number to be a positive. So if we do 2 minus 21, that would be negative 19. So there's the pair that we're looking for. All right, now here's where you've got to remember. Sometimes people will stop here and then they'll solve this thing out. But remember, because we multiplied 7 times 6 in the beginning, these numbers are too big because if we did 2 times 21, that's going to be 42. Since we multiplied by 7 to make this thing even back out, we've got to go back and divide both sides by 7. Okay, and if we do that, this fraction doesn't simplify, so it's just x plus 2 sevenths. But this one's 21 divided by 7, so that's just x minus 3. Okay, and here's the difference. If we were factoring, we would go back and do the bottoms up and have our factor. But since we're solving, we're just going to set both of these expressions, both of these parentheses equal to 0, which means all we're really going to do is once we're here is you just wind up changing both of those signs. So that would be x equals to a negative 2 sevenths. This one, when you change the sign and move it over, you get x equals 3. And that would be our 2 solutions. So in the box that you have down here, where they've got x equals, you basically would go back and put a negative 2 sevenths and then comma and then put in a 3. Okay, so factoring wise, that's the first check you would do. If factoring didn't work, if we went back and there weren't any factors back here that got us to negative 19, that's when you'd have to go back and do the quadratic formula and see what would work. But that's always the first option for me, that if you want to try to find the least amount of work, factoring is the first option. Some people like doing the quadratic formula. And if you're one of those people that you like to do the quadratic formula, you can go back and use the A, B, and C values and plug it back into the quadratic formula and get the same answer. It just depends on which way you want to go there. All right, 15. This one, we're simplifying the expression. We've got 4 plus I. And 8 plus 7i. Okay, and this one's basically just doing double distributive properties. We're going to do 4 times 8, doing a little bit of full method. We'll do 4 times 8 for 32. We'll do 4 times 7i for 28i. And then we'll do 8 times I, and then I times 7i. So I times 8 is 8i. I times 7i is 7i squared. Okay, and then two things to do here. First thing is, the 32 is good where it is. You're going to have these two numbers in the middle that you'll either add or subtract. Since they're all positive, you're just going to add these two together, make that 36i. And the last thing that sometimes people forget is that when you have I squared, you've got to take out the I squared and replace it with -1. So that's 32 plus 36i minus 7. And then you can do 32 minus 7. Just putting these two together. So go ahead and do 32 minus 7, make that 25, and then plus 36i. And that would be your final answer that we're going to put in there. And if you notice on the answer, it tells you even to put this in a plus bi form. So that would be the correct answer that we're looking for there in the correct form. Okay, 17. We're writing the polynomial in standard form, then classify it by degree, and then by the number. So this is one that all we're going to do on this one is pretty short. Standard form, you basically start with your highest power number first, so that's your 2x to the third. The next thing is the x squared. There is no x term, and then we've got just the minus 5. Okay, so start with your highest power, and then just make it go down. For this one, if you notice it, there we go, that would be C. And then you've got a drop-down menu. This is one where you have to check a couple of things. Remember, the plus sign separates the terms. So there's 1, 2, there's 3 terms, which means that's a trinomial. And then the other thing that we're going to do is based on the highest power, which is to the third. And we said the highest power term you have, that's basically going to be the degree that they're going to ask for. So this one, degree is 3. And they may give you 3. They may also say cubic on that part. So we'll just have to see which one they give us here. Okay, so polynomial is okay, there we go. It's cubic. So that's the third power. And then it should be that it's a trinomial. So you need it by the number of terms, which is binomial, trinomial. If you get past that, it's just a polynomial with 4 terms or more. I think if you click on this one, you'll see you basically have the 3 terms. So there you go. So this is 1, 2, 3 terms, and if it's anything more than that, I'll tell you it's a polynomial of 4 terms or 5 terms or whatever the case may be. All right, we'll check it, and we are correct on that one. Okay, 19. Write a polynomial in standard form with the given zeros. Okay, so first thing that we'll do on 19 is we'll start with the zeros that we have. We got x equals 3. We're going to write these out separately every time. X equals -2 and x equals -6. So every how many solutions they have, go ahead and write those things down so that you've got those 3 numbers. So we've got 3, -2, -6. So x is equal to each one of those. And this is when we're going to do everything backwards. That now we've got to set this thing equal to 0. So we're going to move this number, change the sign, and put it back over here with the x. Same thing here. We're going to add 2. And this one we're going to add 6. So basically, they've given you the answers, and now it's like a Jeopardy. They gave you the answers. You got to figure out what the question is. So once we've got those 3 things, then we're going to go back and multiply all these 3 parts together. Okay, so we'll do full method here. We'll do x times x for x squared. We'll do x times 2 for 2x. We'll do -3 times x for -3x, and then -3 times 2 for -6. Okay, and you've got your two middle two terms here that we can put together. So that's x squared minus, and if you want to leave the 1x there for a little bit, that's fine. Because once we get this answer, now we still have to go back and multiply it by x plus 6. So we'll take that x plus 6 and bring it down. And now we're going to do the full method with those numbers one more time. Okay, now, and this is one where I think we talked about this, that sometimes it's a little bit easier, instead of doing the full method and trying to keep up with everything, it might actually be easier to do this like an old long multiplication problem. That you can do 6 times negative 6 and make that negative 36. You can do 6 times negative 1 and make that negative 6x. And you can do 6 times x squared and make that 6x squared. Okay, and then we're going to multiply everything by x. So now it's x times negative 6, and put that underneath this x that's right here. Just like you put a placeholder here. You know, when we did, if you're doing long multiplication, once you got to the second number, you had to put a placeholder. Same thing here. We'll go back and put a placeholder. So we've got x times negative 6 for negative 6. X times negative 1x is negative 1x squared. And then x times x squared would be x to the third. All right, and then put all that together. So we've got x to the third. 6 minus 1 is 5. Negative 6 minus 6 is negative 12. And then the minus 36. And that one should be the first answer. X plus minus 5. Yep, would be the first answer that we've got there. All right, 21. A polynomial function p of x with rational coefficients has the given roots. 2 additional roots are. Okay, so for this one, this is one that you're not having to rewrite anything. This was just saying name more. They gave you 2 answers. They said find 2 more answers. And this is one you just had to kind of know these from some of the notes that we had. That with 21, if you're given 18 plus square root of 3 is one answer. And the other answer was 8i. That basically you just got to change the signs. So if it's 18 plus the square root of 3, the second answer would be 18 minus the square root of 3. And if this answer is a positive 8i, the other answer is going to be a negative 8i. So if they say just name more roots, all you have to do is change the sign. That's it. That's all you have to do. So this one was 18 plus the square root of 3, changed to 18 minus the square root of 3. This one was 8i, so it's a negative 8i. So whatever number they give you, just change the signs, and that's all you have to do. And on this one, again, it should be that you basically just type those numbers straight in. So this one, it should be, it's 18 minus, I have to pull this up real quick. Square root of 3. And it was a negative 8i. And we should be good to go. There we go. Okay, so really simple on that one. If you get that one, just change the signs. Because it's basically saying, all right, we used the quadratic formula to get one answer for this one. So what's the other answer? So if it's 18 plus, the other one's just 18 minus. All right, 23. Simplify by combining like radicals. So if we have 4 square root of 2 plus 3 square root of 2. That as long as the square roots are the same, you just add the numbers in front. So it's 4 plus 3, which would be 7. The square root of 2 does not change, because you can think about each square root being like an x. So this is like 4x plus 3x, which would be 7x. But instead of it being x, it's a square root of 2. If they give you a different square root, it's a different letter. So every time they change, you know, if we say the x is square root of 2, if you're doing square root of 3, then we could think about that as being something like y. So as long as you're adding and subtracting, as long as the square roots are the same, you just add or subtract the numbers that's in front. So this one would just be 7 square root of 2. That's if you had one that was square root of 2 plus the square root of 3, that would be the option where the expression could not be simplified because they have to be the same square roots. If one's square root of 2 and the other one's square root of 3, then that won't work. Now, the one other thing is that let's say you were doing one of these and this one was square root of 12. If you get one that you can break down, well, then you would go ahead and break this thing down and then see if you can add or subtract some like terms. So that's the only catch. If this one's square root of 20 and this one's square root of 12, you've got to take the 20 and break it down. You'd have to take the 12 and break it down, and then go back and see if you can combine like terms from there. Okay. 25. We're solving the equation. We're checking for extraneous solutions. So it's saying, all right, you've got to check the answers because some answers may not make sense. So this is 25. So we've got the square root of 3y plus 3 minus 6 equals 3. Okay, and we're solving for with square roots here. The first thing is you've got to get the square root by itself. So we've got to add the 6 to both sides. So it'll leave you with square root of 3y plus 3 equals 9. And once you're here, only have one thing left to do. Well, one big thing. To get rid of the square root, we're going to have to then square both sides. That if you square root something squared, the square and square root knock each other out. So that would bring us with, bring it back up here, that would be 3y plus 3 equals 81. Subtract the 3. And then take 78 divided by 3, and that should be 26. Okay, but again, it tells us we've got to check for extraneous solutions, which means we've got the answer 26, and the question is, does it really work when we do this thing? If we go back and check it and plug it back in, that means we've got to take the 26 and plug it back into the original thing that we had. So the original problem was 3y plus 3. So we're going to take this 26 and plug it in for the y. So it's 3 times 26 plus 3 minus 6. And the question is, does that equal 3? Okay, so if we do 3 times 26, that was what we did back here, right? That was 78 because we just took this and divided it. So 3 times 26 is 78. Plus 3 is 81. And the square root of 81 is 9. Does 9 minus 6 equals 3? Yes, it does. So it does check. So the answer we got for 26 is the one answer that actually works for this thing. So yes, it does. It checks. Okay, so anytime it says check for extraneous solutions, you've always got to go back and plug that number in and actually make sure that once we get this answer, did it actually work out to be what it needs to be? Because sometimes when you get that answer, it may not actually make sense. So y equals 26 would work. All right, 27. It says perform the operation and find the domain. We've got f plus g of x. So all we're going to do is we're going to take f of x, which is x squared plus x minus 2, and g of x, which is x minus 1. It says to do f plus g, so we're going to take this and add it to that. If it helps, you can put 1s in front of all the x's. So it's 1x squared plus 1x minus 2, and we're just going to add that to 1x minus 1. Okay, so just adding those two things together, we get that. Now you're just combining like terms. It's 1x squared, which is just x squared. You've got 1 plus 1, which is 2. And negative 2 minus 1 would be negative 3. So just adding those two together, we get x squared plus 2x minus 3. Okay, second part. It talks about the domain. And the domain, as long as there's no fractions and there's no square roots, then the domain is all real numbers. So the only time we get any restrictions on the domains when we get all this stuff over here is we'll get less thans or greater thans if it's got a square root in it. If it's got a fraction, then we start leaving numbers off. But there's no fractions and no square roots, so this one would be all real numbers. All right, 29. This is basically just a little log problem that you can use with your calculator. And depending on the calculator you get, they're all going to be something a little bit different. The one thing you can do with this one, is it's log of 64 with base 4. So if you're using your calculator, it's log of 64 divided by log 4. So to put it in the calculator would look something like that. So this is one, again, you have to be a little bit careful. We'll do log of 64. Make sure that if you're using this type calculator, you close off that parentheses. Or if you want to go ahead and equals, that's fine. And then you're going to divide that by the log of 4, close off that parentheses. And you get a 3. All right, just a few more questions. Okay, 31. Multiply and state any restrictions on the variable. So for this one, doing the multiplying first, here's really what it means when you get this question like this, where it says multiply and state the restrictions. Really what it means is when it says multiply, you're really going to factor and cancel. So even though it's a multiplication problem, the way this thing is set up, it's really not a multiplication problem. We're getting kind of close to the end of this class. We'll save a little bit for this one. So if we factor off x squared plus 2x minus 24, the factors of negative 24 that would get us 2 would be x plus 6 and x minus 4. On the bottom, the factors of negative 28 that will get us at 3. Since the b term is positive, it's going to be x plus 7 and x minus 4. 3x plus 21, all you can do is take out the 3, which would leave you x plus 7. And on the bottom, you've got just the x plus 3. Okay, and once you're there, you factored everything. Now you can cancel out the x minus 4s. You can cancel out the x plus 7. And on the top, you're left with 3 times x plus 6. And on the bottom, you're left with x plus 3. Okay, so there's your answer that you're looking for there. And so again, even though it's multiplication, you're really just factoring and canceling. That's really what we're going to do there. All right, 33. This is some trig stuff we had. It says, find the measure of the angle in standard position. This is one where looks like they left off the over 2's on this part because you got square root of 3 and negative 1. That's where you can go back and use that unit circle. And again, you've got yours with you there. I don't have one that's filled in, but if we went back and found it, square root of 3 over 2 and negative 1/2 would be this very first number that's right here. It's asking for the angle measure. And again, this one's going all the way around. So as soon as you're going up, it's positive. That should be 330 degrees. Check it, and answer is correct. So that's one, just use your unit circle. For some reason, the over 2's got left off, but the main thing is it's square root of 3 and then negative 1. All right, and then the last one, 35. Sketch one cycle of the sine graph of the function. We've got y is equal to sine of 2 theta. Okay, and for this one, you've got to, and this is one that sometimes for these, it's a little bit tougher because it doesn't quite always match up exactly. But we can get the main things we need off this part of it. This is where we got to go back and get out our numbers that we've got. Y is equal to A times sine of B theta. That our A is 1 and our B is 2. And the A basically stood for the amplitude. And the B part, that was what we used to help us to get to the period. So we had that one little step in between that was here. So the one thing we know is that the graph is only going to go up as high as +1 and as low as -1. So for this one, that's 1, -1, 1 and -1, 1 and -1, 1 and -1. So we're good there. When we're doing sine, it should start, as long as the A value is positive, you're going up. So this one, it should be going in the up direction. So it's either one of these two. So really it comes down to this period that we get. And for the period, it was 2 pi divided by the B term. So 2 pi divided by 2, the 2's cancel. That leaves you pi. So this thing has to stop at pi. And if you check on this one stops at 2, this one stops at pi. So B should be the correct answer. So if we check it, then we're good to go. Okay, so that was the main thing with sine. The A, whatever number's in front of sine, which in this case was a 1, that tells you what the A value is, and that tells you the highs and lows. That's your amplitude. The number that's in front of the, and again, they'll either put theta or they'll put the x here because it's kind of interchangeable. If that had been 2x, it's still the same thing. That's your B value, which by itself doesn't exactly tell you anything, but what you're doing is that for the period, it's 2 pi over B. And that tells you where this thing should stop after one full cycle of numbers. That gets us there.